Something else that we've recently added, which is quite useful, is geohashing in the suite of available Stellar functions. What geohashing allows you to do is essentially take the latitude and longitude that you get from something like a GeoIP enrichment and translate that into a sort of hash which is less granular. So you avoid a lot of the jitter that you get with very, very fine detailed numbers like latitude and longitude, and start to collect them into what are actually essentially hexagons drawn across the world, which are the geohashes. Now, this allows us to do some quite interesting things, and also some quite fine-grained analysis of use cases like geographically improbable logins. So most systems will do things like, say, you have suddenly logged in from Russia. This is probably bad. What we're looking at here is something which, when combined with a profiler, can be much more personalized. So if you have someone who is, say, maybe commuting, maybe they have a 30-mile commute, and so they tend to log in from home via their VPN within a reasonably limited geographical area, and then they log in from work within a reasonable geographically controlled area, then that it starts to establish a profile for that user's behavior around those two geographical centroids. The geohashing gives us a very efficient way of being able to determine where those centroids are in a way which doesn't jitter too much, and also be able to focus some quite fast analytics down on relatively localized deviation from that. So say we've established this profile which centers them around these two main locations. What we can then do is look at, say, a new incoming login attempt, and that may be from somewhere like Russia or China or the other side of the world, somewhere where they're getting hacked from. That's easy to find, right? What we're also looking for is what happens if, say, they suddenly log in from the next state, which is not a huge distance away necessarily, and so doesn't get picked up by some of those traditional algorithms, but could well be a hacker using something like a proxy access or something like a Tor network. So that very localized exception tracking is very important for finding the more subtle outliers. So if we have a look at some of these records here, what we've got is some synthetic users which log on from a few reasonably close by locations. For each user, we're generating this geohash. So that's the hash, that's their current location for this particular login. We're then profiling that to create the centroid of their normal login. So you can see this geocentroid here. Again, it's a geohash, and we have a variety of different ways of measuring the geographical distance between those. In this instance, we're using an algorithm which accounts for the standard Earth sphere. So we been able to come up with the answer here that these people are about 202 meters away from in this hash. They're about 202 meters away from their regular centroid. So that's not a big deal. We've also then profiled those in a similar way to the way that we did with the authentication data to determine a distribution of this. So this is essentially an indication of how far they travel. So for some of our SEs, that could be quite a large number, and we don't want to over alert on you have a very active traveling salespeople, for example. But if again, we can personalize down to an individual who maybe works in a pretty fixed office role, these numbers are going to be very, very small. So we can be very dynamic about rules we write out of that. So if I look at something which is a little bit different, what I'm actually going to do is I'm going to have one of these users. I'm just going to run this little poison script, which simulates one of the users logging on from an unusual location. So what this is going to do, we'll just wait for that to push some data out there. So, okay, that's pushed in a strange login. And what we have now here is actually, here's one that I did earlier. Right, and that's one that I've just pushed through. So that actually came through pretty quickly. And you'll notice that that has been accounted for as an outlier and has therefore generated an alert. We happen to have scored this as 10 because we're not too worried about geographical logins in this instance, but those scores again, will reflect the full threat triage process that you apply. And if we look at this alert, then again, we've got this reasoning piece here. So that user one, which I just put the strange login from, is actually, they're quite a long way away from it in this instance. So that was a relatively easy one to find. But again, that would have found very, very nearby distances. If you look at the explanation of the rule that we've got here, it's 5 standard deviations. About 40. So we would have found anyone who was about, more than about a kilometer or so away from somewhere that they normally would be from their normal home locations. So we can be very, very fine-grained in that detection and find some of the threats which other systems like this might ignore.